All right, class, in this lesson, you're going to learn to describe the relationship between a quadratic function dilated or multiplied by a linear function as well as its zero. Okay, all right, so let's go ahead and begin. So here's the question. In this example, we're going to take the quadratic function x minus 1 times x plus 3 right here, and we're going to multiply it by the linear function x plus 2, and we need to determine the following. Okay, what is the degree of the product function? Okay, well, the way to calculate this is if you take a look at this function here, well, let's go ahead and write out the product function first. The product function is going to be the quadratic that's given to you, and we're going to multiply this by the linear function x plus 2. Okay, now, if you take a look at all of the x's here, we have an x here, an x here, an x here. So if you were to multiply all of those together, we'd get x cubed. Okay, and what is the exponent here? It is a 3. So that means my degree for this product function is going to be 3. Okay? And then the next question is, what is the leading coefficient? Okay? What is the leading coefficient? Well, we're going to take a look at the same product function again. Let me go ahead and copy this and bring it down here. All right? You want to look at the following. The coefficient is the number just before the x. Okay? Right here, right there, and right there. All right? And that coefficient, or at least the implied coefficient, is a 1. Okay? That's a 1, that's a 1, and that's a 1. And so what you're going to do is multiply all of those together, and we know that 1 times 1 times 1 is equal to 1. So my leading coefficient is 1. All right, next question. What are its zeros? This is basically asking what are the x-intercepts? Well, you're going to take each of these linear portions, the things in parentheses, and you're just going to set each one of those to 0. Okay, so we've got x minus 1 is equal to 0. We have x plus 3 equal to 0, and then x plus 2 equal to 0. And here you just solve for x, all right? So for the first one, we're going to add 1 to both sides. And go ahead and add those up. Okay, and these cancel out, and so now x is equal to 1. For the second one, we're going to subtract 3 on both sides. And we get, with these canceled out, x is equal to negative 3. And then the last one, we're going to do the same thing. We're going to subtract 2 from both sides. And these cancel out. We get x is equal to negative 2. Okay, so then my zeros are going to be 1 comma 0, negative 3 comma 0, and negative 2 comma 0. Okay, so these are my zeros of this function. Okay, now this is a little bit new. We've done this in Math 1, where we would find the y-intercept of a linear function. How do we find the y-intercept of this product function? Well, it's quite straightforward in that we're going to take the function g of x, and instead of x, we're going to replace this with 0, which signifies that every x value in the function gets replaced by 0. So now we have 0 minus 1, 0 plus 3, and 0 plus 2. Okay, this works out to negative 1 times 3 times 2, which is equal to negative 6. So my y-intercept is going to be at 0 comma negative 6. This means that this function, this product function, will cross the y-axis at that point. Okay, now what are the NBA behaviors of this function? This is where we're going to need to graph it, okay? And before we do that, we want to note the following. As x approaches negative infinity, what happens to the function? Okay, and then the second piece is as x approaches positive infinity, what does the function do? Okay, all right, so let's go ahead and graph it. We have g of x is equal to x minus 1 times x plus 3, and x plus 2, okay? We see what this function looks like, and as you will notice, when x moves to the left, my function drops way down to negative infinity, okay? So what that means is as x moves to negative infinity, so we're moving to the left here, my function drops to negative infinity, okay? And then as x moves to the right to positive infinity, what happens to the function? You'll see that in the red line just goes straight up into infinity. So as x goes to positive infinity, my function also goes to positive infinity, okay? So those are our answers. Okay, now let's take a look at the next example. It's going to be similar, but a little bit different. We now have the quadratic function, negative x minus 2 times 2x plus 4, and we're going to dilate that, right? Dilate means we're going to multiply the function by 3x plus 3, all right? So the first 4 questions we can answer without graphing, all right? So what is the degree? Well, let's take a look at the product function. G of x is equal to negative x minus 2 times 2x plus 4 times 3x plus 3. Okay, we have a negative x over here times a 2x. I should probably rewrite that so it's a little bit clearer. Let's put a dot for multiplication. And we're going to multiply this by 3x, okay? And this works out to negative 6x cubed. And we see that this is raised to the power of 3. So once again, my degree here is going to equal 3. Okay, question number 2. What is the leading coefficient? Okay, well, we're going to take a look at the leading coefficient here. Let me go ahead and copy this. My apologies for that. All right, let's go ahead and duplicate this. So we're looking at the following: the coefficient here, the coefficient here, and the coefficient here, okay? We see that coefficient is negative 1. We're going to need to multiply that by 2, and then we're going to need to multiply that by 3, and this works out to negative 6. Okay, so my leading coefficient is negative 6. All right, next question is, what are its zeros, right? Where it's at, whenever you hear the question, what are its zeros? They are looking for the x-intercept. To find the x-intercept, we're going to take each of the following linear functions, so negative x minus 2, and set it equal to 0. We're going to also take 2x plus 4 and set it equal to 0. And then lastly, we're going to take 3x plus 3 and set that equal to 0. Okay? So for the first one, we're going to solve for x. I like to have positive x's, so I'm going to add x's to both sides. Okay, and when we do, these cancel out, and now we have negative 2 is equal to x. Okay, going on to the next one. First thing we're going to do is subtract 4 from both sides. And when we do, we get 2x is equal to negative 4. Okay, these cancel out. And then for the next one, we're going to subtract 3 from both sides, similar to what we just did. And when we do, these cancel out, and we get 3x is equal to negative 3. Okay? Continuing on with this second one, we're going to divide both sides by 2. Okay, and when we do, these cancel out, and so now we have x is equal to -2. And for the third one, we're going to divide both sides by 3. And when we do, x is now equal to -1. So what this means is my zeros are at -2, 0. Notice that both of these are the same. Okay, so we only need to write it once, -2, 0, and -1, 0. Okay, those are our zeros for this product function. Okay, next question, what is the y-intercept? Okay, so we're going to go ahead and take the product function and set it for g of 0, which means we're going to rewrite that product function and just replace all my x's with zeros. 2 times 0 plus 4, and then 3 times 0 plus 3. Okay, simplifying this, we get -2 times 4 times 3, and this works out to -24. Okay, so that means my y-intercept is going to be at 0, -24. Okay, now, last question, what are the end behaviors? Okay, what are the end behaviors? All right, so we're going to need to graph this and determine what happens as x moves to -infinity, as well as when x moves to +infinity. All right, so let's see, my function is -x minus 2, -x minus 2, that was 2x plus 4, and 3x plus 3. Oops, there we go, 3x plus 3. Okay, you'll see that the function, as x moves to the left, my y value, or my function, moves up into +infinity. Okay, and then when x moves to the right to +infinity, my y, my function, or my y, drops down to -infinity. Okay, those are what happens at the end. And so we would say that as x moves to -infinity, the function g of x goes to +infinity. And then as x moves to +infinity, my function g of x moves to -infinity. Okay, now if you notice, let's go ahead and graph this. I'm going to graph the previous function for you. Let's see, what was the previous function? X minus 1, x plus 3, x plus 2. Okay, x minus 1, x plus 3, x plus 2. Okay, if you notice the blue function, that was the first one we did, and you see how the red function, which is the current one that we're working on, is a little different in that it's flipped upside down, right? And why is that? Why is the blue upside down from the red? I know the shape's a little different, but if you take a look at the end behavior, when x moves to -infinity, they're different, okay? Well, why is that? If you take a look at the first function in blue, you notice that the x values, x minus 1, that coefficient in front of the x is a positive number. It's +1. The second one, x plus 3, that coefficient in front of the x is also positive, and then x plus 2, that coefficient in front of the x is positive. And so when you have a positive times a positive times a positive, you have a positive result. Okay, so when the function is positive, we have a graph that looks like the blue one, right? As x moves to -infinity, the function drops to -infinity. So negative and negative, -infinity, -infinity. But with the red, you'll notice that even though 2x plus 4 is positive and 3x plus 3 is positive, the -x minus 2, that negative in front of the x, makes that function negative. And so when the function is negative, it does the exact opposite, meaning that as x moves to -infinity, the function goes to +infinity. And then as x moves to positive infinity, the function goes to negative infinity. So we have the opposite, right? So as x moves to a positive, the function is negative, or if it moves to a negative, then the function moves to a positive. So hopefully that makes sense to you. If you have any questions or something wasn't clear, please go back to the beginning of the video and listen to it again. Thank you.